Hi, everybody. My name is Dan Lindsay. I work for NOAA NESDIS. Welcome to today's Satellite Book Club seminar series. It's number 231. Presentation is titled Warn on Forecast in the Watch to Warning Gap. And our presenter today is Daniel Reese, who is a meteorologist from the Weather Service in Topeka. And our facilitator today is Kristen Cassidy, lead meteorologist from the Wilmington office. A few quick reminders. This session is being recorded per the OCIO Privacy Act guidelines. Please keep your microphone muted and your webcam off throughout the session. See the pinned message in the chat for more info on that. We're going to be having a question and answer session after the presentation. I would encourage the attendees to post your questions in the chat and they'll be fielded that way. If you're logged in under an alias account, please sign in with your full name or specify your full name when asking a question in the chat. We're always looking for future presenters. Please contact the TowerS team if you're interested in presenting. There is a link that Emily just posted in the chat on how to fill out or to fill that out if you're interested in presenting in the future. And lastly, the training team can help create training materials that may be unavailable. Please contact Ross Van Til for information or questions about that. Thank you to the OCLO, GEO and LEO programs and our facilitator today, Kristen Cassidy. Introducing our speaker, Daniel Reese is originally from Middletown, Pennsylvania. He received his bachelor's degree from the University of Oklahoma and his master's from the University of Albany. He's been a meteorologist at the Topeka Weather Service office since 2019. Daniel, welcome to Satellite Book Club. Take it away.
Thanks, Dan, and thanks everyone at the Satellite Book Club for inviting me to present today. It's a pleasure to speak to you all this morning or afternoon if you're on the East Coast. Like Dan said, I'm a meteorologist with the Topeka National Weather Service Forecast Office, and we'll get started here. So I'm guessing most people here are familiar with what Warn on Forecast is, but just as a refresher, Warn on Forecast, or WoFS for short, is basically a rapidly updating high-resolution ensemble system that can quickly incorporate real-time radar and satellite data. It's typically run over smaller domains when relatively higher impact weather is expected, oftentimes severe weather. And it has shown lots of promise at increasing lead time and giving advanced notice of shorter term severe weather. Now at our office, Warn on Forecast is something that we regularly take advantage of on a severe weather day, assuming that there is some sort of WoFS run where the domain covers at least some of our county warning area. And in our operations area, before things really get going, there are usually multiple people looking at WoFS. But overall, the task of reviewing WoFS data primarily falls to the meso analyst. And he or she is going to be looking at that data in combination with all your other meso analysis data, so surface observations, satellite, etc. We'll also get additional insight on WoFS from the Central Region Remote Meso Analyst Google chat room, which can be really helpful sometimes at picking out something within that sea of information that we didn't catch initially, just because there is so much data with WoFS. And over the years, since WoFS has been available, it's been noted that WoFS does tend to perform better after convective initiation when it can incorporate radar data into the system. But there's still a ton of information before convective initiation, and we typically have a bit more time to dig into the data. This is also typically during the gap between the watch and the first warning, when our partners are really looking for critical information on how things will develop. So just with that, I want to take a look at two different events from last spring and see how we used WoFS during that watch to warning gap and how we use satellite data to sort of guide our thoughts on how WoFS was doing. So we'll look at one event where WoFS performed really well and one where it didn't quite as much. So the first event I'll focus on was actually our first severe weather event of the season, March 13th, 2024. Our focus for convection was along and just south of a warm front that was set up generally right around or a little bit south of the Interstate 70 corridor and was slowly lifting north. So the SBC did have an enhanced risk in place for much of our area. If you can go to the next slide there. So it was highest for hail, but all three hazards were possible. We had a 5% tornado risk, 15% for damaging wind, and 30% for the large, potentially very large hail. We can go to the next slide. So The first tornado, or the tornado watch, was issued for a good chunk of our area at 5:45 p.m., 22:45 UTC. And then the first severe thunderstorm warning was issued roughly an hour after that, and the first tornado warning an hour after that. So let's take a look on the next slide here at what WoFS was showing during that 1 hour gap between the watch and warning. So as far as parameters to use in WoFS, there are a lot to choose from. But for the initial development of convection, we typically use just the field that's just probability of composite reflectivity over 40 dBz. So this seems to be a good proxy for the first taller and stronger updraft cores. We don't need precise locations at this point, so using a neighborhood of 15 or 27 kilometers is fine, and will help broad signals stand out better. For this event, you can see that the loop was showing that WoFS was showing a very concentrated area of high probabilities, developing the central Flint Hills to the southwest of Topeka, moving to the northeast over time. You can see that on the loop play, just the initial convection moving to the northeast. We go to the next slide. Beyond convective initiation, looking at probabilities for sphere weather itself, there were a lot of different WoFS fields that we could examine: updraft helicity, hail size, wind speed, vertical vorticity. But to only show one image here, the WoFS machine learning guidance does do a decent job of summing it all up. And for the next 4 hours during this 22 to 2 UTC window, it was highlighting that same Flint Hills area, generally to the southwest of Topeka. So we have a high probability of convective initiation and a high probability that convection will be severe. If we look at each individual member, valid at 7:30 Central Daylight Time, so 0030 UTC, we can show that consistency even better. So if you play the video here, this will just show each of the various WoFS members. We have 18 members in total, and you can see that almost every single member shows one or two dominant supercells developing across portions of the Flint Hills, generally on the southern edge of a larger cluster of developing storms. And most of those members also show a sharp turn to the right, with each of the dominant supercells. So go to the next slide. So what are the observations showing, and do WoFS forecasts agree? For that, we've got to do what we do for any other short-term model guidance: compare to observations. We don't have time today to fully go into the details of everything we're looking at on that day, but the satellite imagery from that day shows a lot. So clouds north of the warm front indicated stability, but where there are two axes of deeper cumulus, where the boundary layer was better mixed and destabilizing. So there's the one east-west axis that I have outlined on the satellite view here, along and just south of the warm front. And then one north-south axis over the Flint Hills. This goes actually a little bit further than the image I have here, and is perhaps indicating some sort of moisture convergence boundary or just deeper moisture overall. But where these two axes of cumulus intersect, we had denser and even more agitated cumulus. I'll play the satellite loop here on the next slide, showing the area of agitated cumulus, and it was lifting north into the same exact area that we saw in the WoFS was depicting the initial convective initiation. We'll go to the next slide. And so with the satellite and observations backing up the concentrated area of WoFS probabilities, we had relatively high confidence that this pretty small area was our main place to watch. So the image on the right here is this exact graphic that we put out on social media and also to our partners around 6 p.m., right within that watch warning gap. So the center of the oval there was basically right where WoFS and satellite were really strongly indicating the imminent development of one or two dominant supercells. We did extend it a little bit east and west to address some of the weaker but still strong convection that several of the WoFS members were hinting at. But that bullseye right in the center there, a little bit west of Topeka, that was really what we were keying in on. And fortunately, this was a pretty rural area. But if storms did manage to get too far east from that, they'd be moving right into the Topeka area. So it's definitely a concern of ours that day. Go to the next slide. We can look at what happened. So we can play the radar loop here. And you'll see that convection took a little bit to get organized. You'll see that times you had a couple different updrafts initially developed, but out of that, you eventually did get a cluster of supercells over the Flint Hills. Out of this cluster, eventually came two dominant supercells, which moved northeast across portions of the Flint Hills, west of Topeka. So we can play that one more time, just so the initial supercells that really took a little bit to get organized. But eventually, north of Council Grove and then moving to the Alta Vista area, we saw that really dominant supercell. You can really see the hook echo briefly there with what it ended up being a couple of tornadoes. So we go to the next slide and look at some of the reports. Perhaps slightly on the northwest side of things where everything really got going. This was basically right in the area that WoFS had been highlighting. So looking at reports, large to very large hail was common in the area. Those are the green dots on your map there on the left. And each of the two main eastern supercells produced an EF2 tornado that both tracked roughly around 10 miles. The most dominant of these supercells, the initial and southernmost one that really had that strong hook echo, actually could have been a violent tornado based on some of the radar data. It did have good fortune to track across one of the most open areas in our forecast area. But overall, just with this event, we got great feedback, and I think it worked about as well as we could hope for with just the convection developing right where WoFS was hinting at, right where satellite was really corroborating that as well. So now let's go to our second event, where pinpointing specific areas was a little bit more challenging. So this event occurred on April 30th, 2024, during what had already been a pretty busy week for us. If you remember the Nebraska outbreak during late April, this was a couple days after that, and we were on the periphery of that, as well as a couple other outbreaks, both north and south of us earlier in the week. So the focus on this day was a cold front moving in from the west, with the expectation that scattered storms, including a few supercells, would develop along the front as it overtook a dry line that was situated over central Kansas. Now, given the increasing frontal forcing, we're expecting the initial more discrete storms to gradually form into more of a line as they move east across the rest of the area. Now, just like the March 13th event, we were in an enhanced risk primarily for hail, but it was still an all hazards type day where a few tornadoes were possible. So we had, again, a 5% tornado risk, 15% damaging wind risk in the immediate area, and 30% large hail in our SBC outlook. So on this day, if you go to the next slide, the watch warning gap really wasn't much of a gap at all. There was just 2 minutes between the tornado watch and the first severe warning. And that was for a reason that we'll get to in a little bit. So we'll take a look at WoFS data from the 19Z run, a bit before the watch was issued, when there were still some questions about exactly where and when convective initiation would take place. So like the March 13th case, we wanted to use WoFS neighborhood probabilities to see if there was any area that WoFS was really honing in on for convective initiation. You notice that in this 19 UTC WoFS run, through around 21 UTC, neighborhood probabilities stayed rather low, below 50%. But even by the latter half of the loop in the 21 to 23 Z window, they stayed lower than what we saw in the March 13th runs. The gradual ramp up in these probabilities gave lower confidence in exact timing and location of convective initiation, though somewhere around 21 UTC seemed most likely. And as far as area, our confidence wasn't much better. The weak signal extended pretty far to the north and south. There's, especially by 21 UTC, there was a noticeable increase in probabilities across the southern half of the forecast area. And machine learning 4-hour severe weather guidance generally mirrored this. If you go to the next slide. So it's definitely highest over the south here, but that does not necessarily mean we should only focus south. So perhaps southern areas may see a faster transition to a linear mode, and northern areas may see just one or two isolated supercells. Or maybe there are just some outlier scenarios that do show development north of I-70. Remember that the machine learning probabilities are still showing some small 10 to 30% probabilities. To dig further into this, we should look at the evolution of the individual WoFS members. So go to the next slide, and each of these next slides are just each individual member of the 18 WoFS members. Each of these will be valid at 2130 UTC. So if we step through here, you'll see that a lot of, overall, there's relatively good agreement south of I-70, but north of I-70, there's a lot of variability in the actual guidance. So you'll see that some are a little further east, some are a little further west. Most of them are relatively weaker with convection north of I-70, but there are one or two members that really show a lot stronger of a updraft helicity tracks that are sort of representative of a strong supercell. And given the environment on this day, that was something that we really needed to watch. So if you go back to number 9, I believe it is. This was the, I think, most outlier WoFS run, and just a little bit of a sneak preview. This is what came close to verifying. So it's really just one or two members that were really hinting at development further west, but there was still enough of a signal that it was in the back of our minds that it was possible. So we go forward a few slides just to the past all the different members. So during severe weather operations, when there's a lot going on and we're short on time, we generally don't have a ton of time to look at these individual members in a lot of detail. So during these situations, looking at 90th percentile or ensemble maximum plots can also do a good job at showing any potential outliers, rather than looking individually and really closely at each particular member. So looking at maximum updraft helicity tracks across the 18 members, we can see a few of these moderately strong tracks here across northern Kansas, north of I-70, which roughly, if you're not familiar with the geography of our earth warming area, it roughly bisects our area. It's an east-west highway moving from, it's about halfway north-south in our area. But still, the most intense updraft helicity tracks and WoFS are in the southern half of our forecast area. So overall, that continues to suggest that that's where we should focus. If you go to the next slide, let's compare these forecasts to satellite observations. And as I play this loop, you'll notice two potential areas of development. And each of these was tied to areas in the various WoFS runs that were highlighted. So to go to the next slide, I've got two areas circled. The most obvious area, so that's around 1930 UTC. I've circled it in yellow, and it's further west right along the cold front. So we'll look at day cloud phase on the next slide. But even invisible, you can tell that the cumulus is quite agitated. I'm going to go back to the first one, just the circled areas. And convective initiation might not be too far away. So the second area that I've circled here in the blue, that's a little further east ahead of the cold front. There didn't seem to be any discernible surface feature here, perhaps some weak moisture convergence. But this was in the area where some of the WoFS members were showing that more eastward development, if you remember each of the different members. So maybe it's something to keep an eye on. Maybe there will be some development over on that area. But also at the same time, there's some hints of stability and more of some cloud wave features in the cumulus further east. So without much forcing, we were a little bit more skeptical that development would occur, especially as it's not quite agitated as along the cold front. So if we go to the next slide now, we'll take a look at the day cloud phase view and examine the cold front area a little bit deeper. It's already beginning to depict a little bit of cloud glaciation along the cold front, suggesting that initiation might not be too far away. And further, a lot of these updrafts, the deeper ones, they're located along or north of I-70, which again is roughly halfway north-south through our area. So the cumulus that we were looking at east of the front, or in that blue circle area I had before, also suggests that moisture might be a little better and deeper further north as well. So that's giving some clues that perhaps some more consideration needs to be placed on those outlier individual WoFS members, with potential development further north and west than we might have initially expected. If I loop this a little bit further in time on the next slide, by 20 UTC, we can already start to see the first signs of connected initiation really starting to take place, with a little more, even a little further cloud glaciation. So these first couple attempts failed, but they indicated that more vigorous and sustained development was not very far away at all. So given this trend, go to the next slide, towards earlier convective initiation and further northwest, we tried to focus on the immediate short term. We made our 3 p.m. social media graphic at 20 UTC. So we only focused on the next hour or so after this graphic was published. And we basically highlighted the entire portion of the cold front within our forecast area. So this was a lot larger area than we highlighted on March 13th. And it's sort of representative of some of the more uncertain thinking we had just based on all the satellite and other information we were taking in. So you go to the next slide, we'll look at the radar loop and see what happened. But as we play the radar loop, you can note that where WoFS was highlighting the most, storms in the southern half of the area stayed weak and largely linear after time, with just a couple of 1-inch hail reports. Meanwhile, further north, 2 powerful discrete supercells have developed and moved to the east-southeast. So these produced really large hail and a couple of tornadoes, including an intense EF3 tornado that hit the town of Westmoreland, and unfortunately did cause 1 fatality. So we go to the next slide here. So this was an area that only a few WoFS members were highlighting in advance for discrete supercells, but a closer look at observations helped keep more of a focus up north. So you can see again all those reports, and there were probably a couple more reports. Some of them fell in quite rural areas east of Westmoreland. So I'm sure there were a couple more large hail reports that didn't quite get to us. With credit though, the 2 main cells, once WoFS was able to initialize on them by around 21 to 22 UTC, it was able to really hone in on a downstream threat as far southeast as Topeka and Lawrence later in the evening. So this is sort of what I went into in the introduction part. Once WoFS is able to better assimilate radar data into the model and get a maybe half an hour to an hour of sustained data into its model, it can generally continue those and have a better idea of what it's going to do downstream. So we go to the next slide. This is just a couple of last takeaways. And overall, the 2 key practices that we took away from this last spring. Now, these weren't really unique to WoFS, but they were particularly useful with WoFS in the watch the warning gap. The first is just to compare forecast to observations. Warn-on forecast has become a crucial part of modern severe weather mesoanalysis. But in severe weather mesoanalysis, observations are king, and they're crucial to knowing when WoFS might be on the right track or not. And the second best practice is to embrace the probabilistic nature of WoFS, which really doesn't exist to this degree in other convective allowing guidance. Ideally, there's a nice big bullseye that we can focus on, like the first event that we looked at. But even if there is uncertainty, like that second event, we can convey why it exists, and that is something that's useful to our partners, being able to tell what our confidence is and why lower confidence might exist. Outlier solutions do occasionally pan out, as we saw with the second one. So recognizing the possibility in advance can help us notice it faster if it starts to occur. And the overall bottom line is this, that WoFS guidance is still at its best after convective initiation, but there's so much information. There's just a wealth of it before initiation, when we typically have more time to go into the details. And this is where critical value can be added to forecast and communicated to partners. So with that, I'll wrap up my portion of the talk and open it up for questions. Once again, thank you so much for having me on here to talk today.
Hey, thanks, Daniel. That was an excellent presentation, and certainly highlights the importance of using WoFS to message in that watch to warning phase of an event. So really appreciate your presentation there. As a reminder, we encourage all attendees to stay on for the discussion, and we'd love to see some participation, especially from those in the field forecast offices and regional headquarters. We also encourage everyone to change their meeting layout to tiled and select hide tiles with video for the remainder of this discussion. Also, we welcome you to share any feedback that you have on this session or the Satellite Book Club in the short survey that's going to be linked in the chat on your right. Again, we recommend attendees to submit questions in the chat room, and we'll kind of go through those one by one as they come through and as time allows. As a reminder, a week from today, Thursday, April 17th at 12 p.m. Eastern Time, John Fulbright from the GOES-R program office will discuss a guide to GOES-R image artifacts. So please put that on your calendar. We also encourage all attendees to contact the Tower S team, including Kashad Bowman and Emily Maddox, for questions about the Satellite Book Club or for configuration of satellite products in general for your office. So again, we're gonna kind of go through any questions that are within the chat here. We'll start with the initial question. This may not be something specifically, Daniel, that you will be able to answer, but the first question we got was from Dan Lindsay. He says, this may be more of a question for WoFS developers, but what observations are used to initialize WoFS machine learning? Any idea on that, Daniel?
Yeah, I definitely don't have a full idea. That is better for some of the WoFS teams, but it's a lot of environmental analysis, at least it's for the machine learning. So environmental analysis, radar trends, but also just, the conglomeration of reports that are in the SBC's archive. And I believe it's trained on some of those. I can't give anything specific to the exact training, but I think it is a lot of observations and environment as well as radar and other model output.
Yeah, Daniel, since I can unmute, I'll just quickly respond to that. What I was thinking is you've done a great job of showing how the satellite observations that you're looking at will sort of inform you of the trends that lead up to the convective initiation. So, and what machine learning is really good at is sort of learning things that we do qualitatively with things like visible imagery. So I wonder if the team at NSSL or our CIRO has tried to actually use the satellite data in the training data set. This is a topic for another satellite book club, but I just thought I would toss that out there.
Yeah, thanks, Dan. I know that it incorporates some satellite data, but yeah, I just don't know quite how much it really takes in that for the machine learning output.
Okay, thanks, Daniel. The next question we have is from Frank. He asks for you, Daniel, did the WoFS output help you at all with the shape of your polygons, especially showing that gradual turn to the right of the supercells?
So it did. That's one of the things we were able to anticipate a little bit sooner, I think, when it actually started to happen. So we had an idea that, especially with the first event, that once we had a dominant supercell, it would start to quickly turn much more to the northeast versus the original storm motion, more to the north-northeast. So once we finally saw the first signs of that turn starting to happen, we were able to react and really get our polygons oriented a lot better, a lot faster than I think we might have originally done.
Thanks, Daniel, for that. Really appreciate the input. This question is kind of a question that I have. You had shown in your two cases using WoFS output specifically for timing and location of convective initiation. Does your office also use WoFS output, I'll call it, during the warning phase to try to highlight specific corridors of different hazards, like using probabilistic hazards information from WoFS, like, probabilities of 50-knot gusts or 2-inch hail? Does your office have a practice of using that information to communicate to partners even during the warning phase of an event?
We do. I didn't show it here, but I had a similar graphic, especially on the first event, compared to basically it was a similar graphic to the first graphic that we showed, and it was a much smaller area, and it was tied to that first supercell in the Flint Hills, a little bit southwest of Topeka, and it really highlighted on the potential for this is where your best strong tornado potential is over the next hour or two. So it wasn't quite as honed in as some of the WoFS data, just because there still was some uncertainty. But we were able to use that WoFS guidance to at least give a much smaller bullseye than we might initially have had.
Yeah, thanks, Daniel, for that input. I know just personally at our office, especially with the increased use of Slack, we tend to get questions from partners, specifically emergency manager partners, asking, is this warning going to be extended downstream? Is this warning going to be extended downstream and whatnot? And we found that using WoFS hazard probability graphics can help provide at least some supplemental information, because obviously we don't want to release pre-decisional warning information in our Slack room. So we definitely use WoFS in that capacity as well. We do have another question. This one is from Jason. He asks, Daniel, does WoFS help you in decision making on hazard end time, specifically, i.e., like when formed storms will decay or move out of your area?
Yeah, that's a great question, and also I think it also goes to Kristin's point on giving partners some information on when a hazard might be allowed to expire or continue downstream. And we actually had an event on April 1st across our area where we had a very narrow axis of more surface-based instability, where we did have a tornado threat with a couple supercells moving. But then as they moved east of that area, temperatures were a little bit cooler and the storms began to be a little more elevated. And WoFS was really addressing that environment well, and showing a sort of decrease in overall low-level rotation, and also just the overall environment as they move east. So we were able to give our partners an update in Slack saying that your tornado threat is highest here, and we're already showing some signs of weakening and just moving into some more stable air. So we're not anticipating on extending this warning beyond this initial one that we have right now. And that was something our partners really appreciated, having that, especially our TV partners that are on the air, and they can give viewers a little bit more of an idea of exactly what's going on and if these downstream communities are at risk. So yeah, that's a great question there.
Yeah, absolutely. Thank you, Daniel. You'd shown two different events here, one where WoFS performed really well, and maybe the other one, it struggled with the initiation location. Have you found that when WoFS does struggle with initiation, that it eventually catches up in terms of, going through time, or does it struggle to really convey the information that you need when it's not getting the initiation exactly correct in time or space?
So yeah, initially I think it does take a little bit for it to catch on, but once it really does have maybe a half hour to hour of a sustained strong updraft to work on, it does tend to do a lot better with that downstream. So for the second event that I talked about, that initial supercell that produced the tornado near Westmoreland that the image of, as that continued on, it really turned more to the east-southeast. and moved right to Topeka, and actually caused some 80-mile-per-hour rear flank downdraft winds right at our office. And that was something, as it moved towards Topeka and eventually Lawrence, WoFS really did get a much better handle on that and showed the downstream threat. So we were able to message ahead of time that this is going to continue in especially northern portions of Topeka and Lawrence and areas further north of there. I really need to watch out. So that was something that was certainly helpful once we did get a better handle on things.
Okay, thanks, Daniel, for that. So we know that you obviously kind of highlighted two specific events here. Do you have any input or thoughts on just kind of some consistent biases on WoFS within your area, whether that's initiation or hazard probabilities that kind of extend beyond the scope of just these two events that you highlighted?
Yeah, so I didn't notice anything too specific, either with these events or throughout the season. If anything, there may have been a slight eastward bias with some trends in just short-term convection, and that was something that was mentioned at a presentation in AMS back in January. I didn't quite get a chance to catch all of that one, but there was some talk about there might have been a slight eastward convection or bias in the short term with WoFS. So that'll be something that to keep an eye on, but it didn't seem too strong overall. Perhaps a few occasions here and there, but it wasn't something that we noticed really every single event or in a super strong degree. And as far as timing seemed pretty good throughout most of the events that we looked. Some were slightly earlier, slightly later, but when you had, they were generally within the, usually within the higher probabilities of convective initiation timing and the WoFS ensemble members.
Yeah, absolutely. Thanks for your input on that. You mentioned that the person in your forecast office who is routinely looking at WoFS output is kind of the person in charge of mesoanalysis, and they're in the mesoanalyst role, and also getting input potentially from the RMA chat room. Have you found that it's too much information for the mesoanalyst to digest, or have you found kind of that you have a good strategy for kind of dissecting all of this data that's coming to you at once?
That's a great question. I think at times it can be almost too much information just with everything that's there. But I think we have developed some strategies to really focus on. And like I sort of mentioned here, in a warning operations event, it's kind of hard to look at every single ensemble member. So it's really not even something that we really do once storms have actually developed. We tend to look at more of the either 90th or max percentile graphics, as well as some neighborhood probabilities and just some of those other ones that can sort of conglomerate some of the individual runs a lot better. And also rely on the mesoanalysis chat room, where a lot of those RMA experts, they might have more time to look at some of those things and can sort of parse out perhaps a little bit better some of the more important things that are standing out in WoFS a little bit easier than we can. And also compare those observations or in WoFS forecasts to other mesoanalysis observations, because being able to combine those is really important, as I mentioned, whether it's satellite or other mesoanalysis field surface observations. It's always important to do.
Yeah, thanks for that, Daniel. Yeah, it's tough trying to balance all of this information coming in at once. It's all great information, but locally it's a challenge, especially when you have storms kind of all over your CWA and you're trying to analyze data sets from different areas. So we appreciate your input on that. I don't see any additional questions in the chat room at this time. So I will send it back to Dan Lindsay for any final remarks.
All right. Thank you so much, Daniel and Kristen, for leading an excellent discussion and an excellent presentation. As we previously mentioned, remember that a week from today, John Fulbright from the GOES-R Program Office is going to discuss a guide to GOES-R image artifacts. So that'll end the session for today. Thanks a lot for joining.